Hello student, welcome to the course Control System. I am Professor Vibhagon from Department of Electronics and Communication Engineering at Tulsi Ramji Gaikwad Patil College of Engineering and Technology. Today I want to discuss here control system. What is the control system? Classification of control system, open loop control system, then closed loop control system. And difference between the open loop and closed loop control system, transfer function, then Laplace transform, and types of feedback. Control system. Control system is a way of arrangement and combination of elements or components to provide high stability, high speed, minimum error, and desired output. These are the input and output. Input is sometimes enter into a machine or other system in order to produce the output. The output actual response obtained from a system is called output. Classification of control system. There are many types of control system. First is the natural control system. Natural control system, a control system that occur naturally without human intervention. And example of the natural control system, human body temperature regulations. And next is the man-made control system. Man-made control system, a control system designed and developed by the human to perform specific tasks. Example of man-made control system, traffic light control system. Then automatic control system, a system that operates automatically with the minimal or no human involvement. Example of automatic control system, automatic washing machine. Then combinational control system, a system formed by the combining two or more control technique to achieve desired performance. Example of combinational control system, automated industrial process control. Then time variant and time invariant control system. Time variant system parameter change with the time, and time invariant system parameter remain constant over a time. Example, battery performance changing with a age. Then linear and non-linear system. Linear system, output is directly proportional to the input, and non-linear system, output is directly proportional to the input. Example of linear system, amplifier, and example of non-linear system, saturation effect. Then continuous time and discrete time control system. Continuous time, signal change continuously with the time, and discrete signal are proceed at specific time interval. Example of continuous analog temperature control and discrete controller discrete signal example, discrete controller. Single input, single output. One input and one output. Multiple input and multiple output. Example of single input, single output, fan speed control, and multiple input, multiple output. Example, aircraft control system. Open loop and closed loop control system I will discuss in next slide. Open loop control system. A open loop control system use the actuating device to control the process directly without using feedback and without measuring output. And here controller and plant both are connected in a series. Example of open loop control system, electric switch and traffic signal. First, I want to discuss here electric switch. An electric switch is a good example of an open loop system because output is light and switch is a controller of the lamp. There is no effect on the on-off position of the switch due to any changes of the light. And another example of open loop control system, traffic signal. For automatic control of traffic, the lamp of three different colors, red, yellow and green, are used. The time for each lamp is a fixed. The operation of each lamp does not depend upon the density of the traffic, but depend upon the fixed time. So we can say that the control system which operates on the time basis is open loop system. Closed loop control system. In these types of system, output is continuously measured and compared with the desired value of feedback output. Here in this diagram, the controller and plant both are connected in a series via feedback element, and here error is generated, which is difference between the input signal and feedback signal. This error signal is the input of the controller and actuating signal is output of the controller, and this actuating signal is a plant input of the plant, and so we get out the desired output. And example of the closed loop control system: automatic electric iron and temperature control system, voltage stabilizer. Example of electric iron: closed loop control system, automatic electric iron. Automatic electric iron regulate the temperature of iron in such a way that the temperature for a specific cloth remain in a specified range. Difference between the open loop and closed loop control system. In open loop system, output measure is not necessary, simple and most economical, error detector is not presented, and work on time basis. But in closed loop system, output measure is necessary. It's very complicated to construct and costly. Error detector is present, work on comparison basis. Example of open loop system: electric switch, traffic signal, washing machine, bread toaster, etc. And example of closed loop system: uh, electric iron, railway reservation status display, etc. Transfer function. Transfer function of any physical is that mathematical function from which we can determine the complete dynamic behavior of any system. It is an operational method of analyzing the performance of the system in terms of time response, accuracy, and stability. And it is the mathematical defined for any linear time invariant system. Transfer function is defined as the ratio of the Laplace transform of the output to Laplace transform input if all the initial conditions are assumed to be 0. This is the transfer function of the system, and input of the transfer function and output of the transfer function, and zero initial in the zero initial condition. Transfer Laplace transform. Laplace transform solution of any physical problem can be obtained by the time domain approaches or by frequency domain approaches. It is the conversion of time domain to frequency domain function is known as the transformation. The reverse process is called the inverse transformation. There are two types of transformation: Fourier transformation and second Laplace transform. But I want to discuss here Laplace transform. Laplace transform, the performance of an automatic control system are used mathematical tools in Laplace transformation. The Laplace transform of the function f of t is defined as the L f of t equal to f of s, where f of s is symbol of the Laplace transform and L is the Laplace transform operators, and f of t is the sum function of time t. Time t. Types of feedback. There are two types of feedback: positive feedback and negative feedback. Positive feedback. Positive feedback, the set point and output values are added together by the controller as the feedback in is in phase with the input, and effect of the positive feedback is to increase the system gain, and so t equal to z upon 1 minus z of h. And next is the negative feedback. Negative feedback control system, the set point and output value are subtract from each other as the feedback is output of phase with the original input. The effect of negative feedback is to reduce the gain, and t equal to g upon 1 plus g of h. Thank you, student.